If you're following along on the class notes, and I hope that you are, we are on page 11 and chapter 4 notes on the time value of money. And we're going to take a look now at finding the present value of $1,000 per year for 5 years with a discount rate of 5% annual compounding. Let's bring up the whiteboard and show how this is working here. So we're standing here at time 0, and here's 1, 2, 3, 4, and 5. And you're going to receive $1,000 here at time 1. You're going to receive $1,000 here at time 5, and $1,000 each year in between. So 5 separate cash flows, $1,000 each. And we want to know what is the present value. Now, we can do this the long way. We can say 1,000, the interest rate, by the way, is 5%. We can take $1,000 here and bring it back to time 0. Take this $1,000, bring it back to time 0. Take this $1,000, bring it back to time 0. And we can do each one of them individually. and that's great. It'll work. We want to see a shortcut, though. So let me show you in our class notes, first of all, the long way of doing it. Okay, so the long way of doing this is right up here. So we see here's the first $1,000 divided by 1.05 to the first power. And of course, we don't need to put the number 1 up there for the first power. Plus 1,000 divided by 1.05 squared, plus 1,000 divided by 1.05 cubed, plus 1,000 divided by 1.05 to the 4th, plus 1,000 divided by 1.05 to the 5th. So they're all at time 0. You can add them all up safely without messing up the space-time continuum. And we get the present value is $4,329.48. Now, if we want to do this in Excel, we're going to introduce now the payment function in Excel. So let's bring up Excel here. And take just a second here. And okay, so I think we can get Excel up now. There we go. So what we're going to do here is we're going to say, again, equals PV for present value, put our bracket in there, and we're going to save ourselves a little bit of time here, okay, with the use of the PMT function. Our interest rate is 5%, 0.05, or I could type in 5%. The number of periods is 5, and under payment, PMT, we're going to put $1,000. If I put it in as a positive, my answer would be a negative. If I put it in as a negative, my answer will be a positive. I'll put it in as a positive. 1,000. So there's $1,000 under the payment. What this means to Excel, it means there's going to be $1,000 is going to be the cash flow in each of these 5 periods here. So whatever is the number you put, a number of periods, that's how many times you're going to be receiving if it's a positive number, paying out if it's a negative number, receiving the $1,000. So future value we leave blank because there's nothing in the future in addition to these 5 payments of $1,000. So 5 times there's going to be $1,000, then nothing else on top of that. Type, we haven't learned about what that is yet. So we're going to hit OK. And the answer is $4,329.48. And what Excel has done here, if we go back to our class notes, what Excel has done is exactly what we showed right up there. It took those 5 payments of $1,000, which were in times 1, 2, 3, 4, and 5, brought them each back to time 0 at 5%, and got that answer, $4,329.48. So the PMT function or payment function in Excel means that we have the same amount of money each one of those compounding periods. Now, if one of these was $900 or $1,100 or $2,000, you can't use it. The payment function in Excel only works when you have the exact same number of dollars each one of those compounding periods. But we have that a lot in finance, so it is going to be used quite frequently. Well, this is used so frequently that we want to make sure that we understand exactly what it means when we say 4,329.48 is the present value of $1,000 per year for 5 years at a discount rate of 5%. So let's suppose that you go to a bank and you deposit in the bank $4,329.48. Well, if it's going to be earning 5% interest, at the end of the year, you earn 5% on the $4,329.48. Well, 5% of $4,329.48 is $216.47. In other words, take this right here, multiply it by 0.05, and that's what you're going to get. So that is your interest that you earn at the end of the year, because we have annual compounding. So when we add that to the 4,329.48, in other words, add this and this together, here's how much money you have in your account at the end of the year with the interest added on. Well, let's suppose at the end of this year, you say, hey, I've got $4,545.95. I'd like to withdraw $1,000 and I'd like to, excuse me, I'd like to go on a Caribbean cruise. So you take out the $1,000 and that leaves you $3,545.95. So that's what you have at the end of the first year after you have withdrawn $1,000. And of course, after you've earned your 5% interest on what you had at the start of the year. Well, the end of year one is also the beginning of year two. So this is how much money you have here at the beginning of year two, the same amount that you had at the end of year one. During year two, this money is earning 5% interest. 5% of $3,545.95 is $177.30. Annual compounding, so that money comes to you at the end of the year. And when it gets added to the money you had at the beginning of the year, you now have a total in your bank account of $3,723.25. Well, you look at that and you say, you know what? I think I'd like to withdraw $1,000 and I'd like to go skiing up in Aspen. So you take out the $1,000 for your ski trip. And so that leaves you with $2,723.25. Well, if that's what you have at the end of year two, that's also what you're going to have at the beginning of year three. During year three, that money is going to be earning you 5% interest. 5% of $2,723.25 is $136.16. You receive that money at the end of the year because we have annual compounding. So when that gets added to what you had at the start of the year, you're going to have $2,859.41. You decide to take out $1,000 from that because this time what you'd like to do is you'd like to go hiking in Yellowstone Park, and you take out the $1,000 and that leaves you with $1,859.41. That's at the end of year three. So that's also what is in your account at the beginning of year four. During year four, that money is earning 5%. 5% of $1,859.41 is going to be $92.97. That gets added to your account at the end of year four, bringing your account total to $1,952.38. You look at that and you say, man, I think I'd like to take out $1,000 and go scuba diving off the Florida Keys. So you pull out your $1,000 and that leaves you with $952.38. That's at the end of year four, which also means that's what you're going to have at the beginning of year five. During year five, that's earning 5%. 5% of $952.38 is $47.62, which gets added to your account at the end of the year, giving you a total of $1,000 in your account. Exactly $1,000, which you decide to pull out, because this year you decide you want to just fly out to Hawaii for the weekend. So you fly out to Hawaii for the weekend, fly back, and that leaves you exactly $0 in your account. Coincidence? No. The whole idea was, we said, if I wanted to pull out $1,000 each year for 5 years, and my money is earning 5% interest, what do I need to start with? And we needed to start with $4,329.48. So that's what we mean by the present value of $1,000 per year for 5 years. Going back to our whiteboard, what we're saying is that the 4,000, the present value right here, the $4,329.48. If we have that today, and whatever is in the bank account is earning 5%, I have enough money that I can pull out $1,000 at the end of each of these 5 years. So we don't need $5,000 to pull out $1,000 5 times, because whatever is in there is earning 5%. What do we need? $4,329.48. So having $4,329.48 today is equivalent to having $1,000 each year for 5 years. Because if I had that $4,329.48 today, I can invest it at 5% and use that, as we saw, to pull out $1,000 each year for 5 years. Well, what happens if I want to do this not just for 5 years, but I want to do it forever? I want to continue to pull out that $1,000 every year for the rest of my life, I want to leave the money to my kids, have them pull it out every year for the rest of their lives, for my grandkids, forever. We really love these $1,000 vacations. So we want that to go on forever and ever and ever. How much money do we need to deposit into the account at time 0? Well, clearly it's got to be more than $4,329.48, because that runs out at the end of 5 years. Well, it's not as much as you might think. The amount of money you need to deposit into the bank is $20,000. Because if I deposit $20,000 into the bank at time 0, and it earns 5% interest, 5% of $20,000 is $1,000. So at time 1, what I've got in my bank account is $21,000, right? The $20,000 I deposited plus 5% interest, which is another $1,000, brings me to $21,000. I pull out $1,000, go on the vacation, and what's left? $20,000. That money is going to earn 5% during the second year. And then at the end of year 2, I've got $21,000 in my account. I pull out $1,000 to go on my vacation, leaving me with $20,000. And then that $20,000 earns interest during the third year. How much interest does it get? Well, 5% of $20,000 is $1,000. So we're now at time 3, I got $21,000, pull out $1,000 to go on my vacation, leaving me with $20,000. How long can we do this for? You got it. You can do it forever. So that there's a special name to this. It's called a perpetuity. A perpetuity is a level stream of cash flows that goes on forever. So in this example, it's $1,000 per year forever. That is a perpetuity. If it's not the same number of dollars every single time period, it's not a perpetuity. If it doesn't go on forever, it's not a perpetuity. So this is what a perpetuity is. It's a level stream of cash flows that goes on forever. Now, the easiest formula that you will ever see in finance is the present value of a perpetuity formula. Present value of a perpetuity is simply equal to the cash flow divided by the discount rate, R. Okay, so the cash flow divided by R is simply going to be the present value of the perpetuity. In our example, the cash flow was $1,000 per year, and the interest rate, R, was 5%, 0.05. 1,000 divided by 0.05 is equal to 20,000. So that was the present value of the perpetuity. That was how much you needed at time 0 to be able to produce a cash flow of $1,000 per year forever. That's a perpetuity. Now, the second cousin of a perpetuity is an annuity. An annuity is a level stream of cash flows that doesn't last forever. It stops at some point in time. That was the $1,000 per year for 5 years that we did. When we did the vacation for just 5 years and then it stopped after 5 years, that was an annuity. So an annuity is a level stream of cash flows that comes to an end at some point in time. A perpetuity is a level stream of cash flows that goes on forever. Think of it this way. A perpetuity is like true love. It goes on forever and ever and never ends. An annuity, that's more like a summer fling. It stops at some point in time. So present value of a perpetuity, level stream of cash flows that go on forever. Present value of an annuity, level stream of cash flows that stop at some point in time. Well, we've seen the formula for the present value of a perpetuity. Very simple there. The formula for the present value of an annuity is a little bit more complex, but not much. Now, I show you how we actually derive this formula at the bottom of page 12 and the top of page 13 of your notes. Now, you don't have to understand how it is derived, but it's not too difficult to do it. And for some of you engineers out there, I know you really need to see how formulas are derived. You don't want to just accept them the way they are. So the present value of an annuity is going to be equal to the cash flow times 1 over R minus 1 over R times 1 plus R to the T. And we're going to use this a lot in our course because annuities are very frequently used in finance. So the cash flow is how much dollars you're taking out. So in our example of the vacations for 5 years, the cash flows were $1,000. R is the discount rate. Now it appears 3 different times, but it's going to be the same number each time. In our case, it was 5%, which was 0.05. And T is going to be how many times we are getting this cash flow of $1,000. We get it 5 times. So T is how many times we're getting the cash flow. So if you do the math on this, okay, you're going to get an answer of $4,329.48. Now, I don't expect you to do the math on it, but I do want you to know that this is the math problem that Excel is solving. I expect you to be able to set it up this way, but then you go into Excel, and when you go into Excel, you're going to put in the $1,000 as under PMT, okay? You're going to put 5% in under rate, and you're going to put the number 5 in under NPER. Okay, so T, which is 5, is going to be your NPER in Excel. R in the formula, which is 5%, is going to be under the rate in Excel. The C, which is $1,000 in our formula, is going to be PMT in Excel, and it's going to give you the present value of $4,329.48, which we've already gone through and done there. So that's now, how do you find in Excel the present value of the perpetuity? Well, there's no formula in Excel because it's just so simple. You just do 1,000 divided by 0.05 gives you $20,000. Okay, there's not a pre-programmed formula in Excel. We said there's not pre-programmed formulas for everything. There is for a lot of things, but not everything. And a perpetuity is one of those things that it's not. Well, in our next couple of videos, we're going to take a look at a couple of examples of perpetuities. We're going to look at a couple of examples of annuities. And one of them is going to be something that is kind of fun to look at, but probably won't happen with most of us. The other one is something that's not nearly as much fun, but probably will happen with most of us. So to find out what those are going to be, you're just going to have to watch the next video.